Hey guys, today we're going to be solving the increasing triplet subsequence problem. We're given an integer array and we have to return true if there exists a triple of indices that are all different and all increasing. So I has to be less than j, which has to be less than k. And all of the numbers belonging to those indices must also be increasing. So k has to be bigger than j, which has to be bigger than I. So just pick any three numbers in order in this array that are increasing. And that's what we're looking for. And we just want to return whether this array has one of those triplets or not. So we're just returning a Boolean. How can we solve this problem? Well, the obvious brute force solution is just to look at, define three indices, I, j, and k. Let's write them in. Then we're going to go through every single triplet in this array and ask if the value at k is greater than the value at j, and if the value at j is greater than the value at I. In this example, of course, it would return right away and say, yes, okay, we see one. But you can imagine if we, for example, reversed this array, we would have to keep incrementing k all the way to the end, and then we'd have to increment j, reset k, move k up again, then increment j again, look at this number, then we have to increment I, reset j and k, so on and so forth. So what would be the time complexity of this brute force algorithm? It's looking like big O n cubed to me. Not very good. How can we improve this runtime? There's kind of a hint in this problem. It says, follow-up. Could you implement a solution that runs in big O n time complexity and big O1 space complexity? So can we solve this problem using linear time and linear space? Well, I mean, I don't think they would ask if we couldn't. So how do we do that? This suggests that we're going to go through this array one time, because it's linear time, and figure out if there's a triplet in here that has incrementing values. So we're going to have to, I guess, have a pointer. Or I guess our iterator that's looking at a value, and it's going to go through this whole array. The idea is to keep track of two separate minimum values. Okay? So the idea is that if you have two minimums that you've seen so far, and then you see a number that is not smaller than either of those minimums, is not smaller than or equal to, then it has to be bigger by default, or by process of elimination. It has to be bigger, which means that you found yourself a triplet. Okay, so how do we do that? Well, it might just be easier to look at the code at this point. Let's check it out. Okay, so I define a first min, and that value is infinity. It is not even, it's an incomprehensibly large number. And the same goes for second min. So anything is that any number that we see is going to be less than these values, any defined number. So we're going to go through n in nums, and the value pointed at I will be n. Maybe I'm just going to call this n. just to make it more straightforward. So we're looking at n, which is 1. Okay. And our mins are going to be like, let's do first min is, I cannot draw infinity. There we go. And let's do second min there. Okay. So we start with we start with our n here. Looking at the first index, value is 1. So we check if n is less than or equal to the first min, which it is, then we set the first min to be n. Okay. So we set it to be 1. And we continue because we have an if, else. All right. So now we move n. Let's move n forwards. Okay, we're looking at 2 now. All right. We ask ourselves, if n is less than or equal to the first min, then we set first min to be this n again, right? But 2 is not less than or equal to 1. So, else if n is less than or equal to second min, if 2 is less than or equal to infinity, we set second min to be n, which is 2. All right, and then we continue forwards again. Okay, now in this iteration here, we've got our first and second min, and maybe if I don't know, I'll indicate first min in purple, so it's looking there. Second min is going to be in fat green for some reason. Okay, so we got our first and second min. Now we're looking at n. And is 3 less than or equal to 1? No. Is it less than or equal to 2? No. Okay. So if that's the case, if this n is not less than or equal to either of these, and these two are each separate minimums, then by process of elimination, this n has to be greater than both of these numbers, giving us a triplet. And so we can return true. We could end the video there, but I'm going to go through a more challenging example because this problem and the solution itself is a little bit hard to understand. So let's try this. Okay, let's draw our n, and I'll just call first min f, second min is s. Right now they're both infinity. Okay. All right, so we're looking at our value 1 here. Automatically it's going to get assigned there. We're going to move n forwards. Okay. Since 6 is not less than or equal to 1, this is going to be the next minimum that we've encountered. Okay. All right, let's grab that n again and let's move forwards again. Okay. So what happens here? We're looking at a 2, and we check, okay, is 2 less than or equal to the first min that we found? And if so, let's set our first min to be this. It's not, so we don't do that. Is it less than or equal to our second min? Yes, it is. So we're going to set our second min to be 2. Okay, cool. We're going to increment again. We're looking at 5. Now 5 is not less than either of these, and we know that our first min and our second min are different because we're basically overwriting the first min anytime we see a minimum that's less than or equal to the first min. And then it will only evaluate this condition, hence why we have this else if here. So we'll only set the second min if that first condition passes, where the first min is checked first and set first. So that is really the concept to hammer into your head. Okay, at this point, we would see the 5. It's not less than or equal to either of these minimums. So that means it has to be bigger. So we return true. I hope that made sense. Try it yourself. Use some of these test cases here. Try and break it if you can. And make sure that you understand it on your own. Okay, take care.